5.1, operations with polynomial. We're going to spend a couple days on 5.1. Okay. Some of this will be review, I hope. Some of it's going to be new, and then we're going to build from there. Okay, so we're just going to jump right in with the problem. Okay. So go ahead and write this down and give it a shot. See if you can figure out what you're supposed to do here. Obviously, it's a multiplication problem, right? I've got two sets of, these are called monomials. It's one term times another term. We're dealing with different variables and powers and things, and see what you can come up with there. So let's talk about how to break this down, right? We want to look at it in three different parts. We want to look at the numbers in front, those are known as coefficients, and just deal with that. Then we want to look at the A's, then we want to look at the B's, okay? And so you want to think of them separately, even though they're really all together, all right? So for starters, in the green, 2 times negative 4, what's that? Negative 8, okay? In blue, we've got a to the third times a to the second. What do you do when you're multiplying exponents? What do you do with the powers when the base is the same? Yeah, Dylan? Add them, that's correct. Okay, so put that in blue, will be super color coordinated. So what is it? A to the what? Fifth power. Okay? Now, adding, so we've got b to the negative 2, b to the fourth. What do I do with those powers? You still add them, right? Negative 2 plus 4 is what? 2. So that becomes b squared. How many of you had that? Okay, good. So let's keep in mind our power rules, okay? When you have exponents with the same base and you're multiplying, you just add the powers. And let me show you really quickly why we do that. All right, now I'll just look at a to the third and a to the second. Because what does a to the third actually mean?
A times A times A.
A times A times A. And what's a squared then?
A times A.
Okay, so this is a times A times A times A times A, which is just a to the fifth. That's why it works. That's why we add the powers. Because in reality, exponents are there so we don't have to write all the a's out, or all the b's out, or whatever it is. Okay? And so, in reality, we're still multiplying, but we're adding the powers. Okay, so what do you think we do when it's division? And when we multiply here, we added the powers. What do you think we do when it's division? Subtract. Subtract the powers, okay? So let's look at an example of that. So here are 3 examples, actually. Okay? Be careful on C. That one's a little tricky. Go ahead and write those down and then simplify those. And we'll see what you got. You're always going to subtract the bottom power from the top power. So top power minus bottom power. Top power minus bottom power. There we go. So, as I said, when the bases are the same and you divide, you subtract the powers. Top minus bottom. So in reality, what this is x to the 2 minus 6. Okay, which is what? Negative 4. And on day 2 of this, it has, actually I think it's going to be Wednesday, we're going to talk about how to deal with negative powers. Okay, but for now we're going to just leave it like that. Okay, and on part B, even though there are numbers, we don't do this problem any differently. Okay, I know that some of you, more than one, divided 3 divided by 3 and made it a 1. Okay, you didn't do that with the x. You didn't make this a 1. So why would you do that with the 3? And I get why you did that, because you see the 3 divided by 3 and you think, okay, well, I should just divide those. Well, in reality, it's the same situation. This is 3 to the 3 minus 5, which is 3 to the negative 2. Okay, and if you wanted to prove it, this is 3 times 3 times 3 over 3 times 3 times 3 times 3 times 3, right? So those cancel, and I'm left with 1 with 2 3's on the bottom, and those are equal to this, and that's what the negative powers are all about. And we'll get to that in a couple days. Okay? This one is trickier. I want you to Look at this, 4 over 12. Just by itself. What is 4 over 12 if I reduce that fraction? Because that's what it is. It's a fraction, right? This is 4 over 12. It is not 12 over 4. What is 4 over 12 reduced? Yeah, Isabel? 1/3. Okay, so I saw a bunch of 3's. If it was 12 over 4, then it would be 3. 4 over 12 reduces. I divide top and bottom by 4, and I get 1/3. Okay? So I treat it separately. I treat them differently. The regular numbers without the powers, let's see if I can split that better. I treat a little differently. That's the best I'm going to get. Okay? And then I've got the x to the 4 minus 7, which is -3. How many had all 3 of those correct? Raise your hand. How many had 2 out of 3 correct? All right, good. Any questions before we move on? There's all the answers. All right, there's the next part of this lesson. Okay, I'm breaking this lesson down into 3 topics. 2 of them we're going to cover today. So first, we have to look at this word polynomial. Okay, we're going to have some criteria to determine if an expression is a polynomial. Remember, an expression is different than an equation. It's like half of an equation. Doesn't have an equal sign. It's just a bunch of numbers and variables and maybe some addition and subtraction, maybe some multiplication and division, but no equal sign. Okay, so we're going to determine if an expression is a polynomial. So here's the criteria. First off, there are no variables in denominators. And if you remember when we talked about linear expressions way back in chapter 2, this was also one of our rules for that. If there is a variable in a denominator, it couldn't be linear. Well, if there's a variable in a denominator, it can't be a polynomial either. So if I have a variable also with a negative power, and like I said, we'll learn about that a little more in a couple days, that really means you have a variable in a denominator. So if either of those things occur, it's not a polynomial. Next. No variables in radicals or under radicals. Remember, radicals like a square root sign. Can't have a variable there either. When you're asked to determine if something is a polynomial, you have to say if it's a polynomial, you just say this. There's no variables in denominators and no variables in radicals, therefore it's a polynomial. Okay? If it isn't a polynomial, you would say something like, there's a variable in the denominator, so it's not a polynomial. Or there's a variable under the radical, so it's not a polynomial. Okay, so we've got examples here. And we're going to go through each one and talk about how you are supposed to decide if it's a polynomial or not. Okay. So let's start right off the bat with this first one. 3x plus 4y. Is there a variable in a denominator? No. Is there a variable in a radical? No. So what can we say about this? It's a polynomial. Okay. And my explanation would be, and I'm not going to write it out because I don't have enough space, but you would need to do this on your homework. Your explanation is no variables in denominators or radicals. And you're good. Okay. How about number 2? Think it's a polynomial?
No.
Why?
There's a variable in the radical.
Variable and a radical right here. So what you would say is not a polynomial. And your reason would be there's a variable in a denominator. Or sorry, in a radical. There's a variable in a radical. Questions on that? How about 3?
No.
Why not?
Variable in the
Variable to a negative power. So this is not as well, and you'd say there's a variable to a negative power. Or variable in a denominator. This is the same thing. And again, in a couple days we'll talk about that more. How about 4? How many, raise your hand if you think yes, it is a polynomial. Raise your hand if you think no, it is not a polynomial. Raise your hand if you're uncommitted and have commitment issues. 2 of you, okay. Is there a variable in a denominator? There's no radicals here, right? I don't see a square root anywhere. Is there a variable in a denominator? Obviously, this is the area in question, right? Because here it's clearly not. Is this x squared in the denominator, in the numerator? What?
No, it's being multiplied, right?
Right. So if I was going to multiply, I could actually put this over 1, which means it's really in the top, not in the bottom. So this is a polynomial. A variable next to a fraction does not mean it is in the denominator. So again, what I would say is no variable in a denominator or a radical. Next part of the lesson is what's called the degree of a polynomial. Ooh, there is a typo. Let's fix it. Degree of a mononomial. There, that's better. It's probably going to be wrong on the next slide too. Degree of a monomial is the highest power on the variable. So those monomials, those were the things that we were working on at the very beginning of the lesson when we multiplied those things together, where it was just a bunch of variables and numbers put together without a plus or minus in between them. That's a monomial. So the highest power on the variable is the degree. And one of the things that we haven't really talked about yet, but I want to tie back, is linear expressions have a degree of 1. Quadratics that we did in chapter 4, quadratics have a degree of 2. Okay, eventually, later on down the road, you might learn about cubics. They have a degree of 3. And then quartics, they have a degree of 4. And we'll get into that a little bit here. Okay. So, in these are 3 monomials. I have to fix this, otherwise it'll make me crazy. Oh, I didn't want to do that. Okay. So for the first one, what is the highest power on the variable? Yeah, so it's just 2. So the degree of this term is 2. Okay, highest power on the variable here? 5. So the degree is 5. Highest power on the variable here? 3. Okay, so for the first one, the degree is 2. Second one, the degree is 5. Third one, the degree is 3. We saw things like this in quadratic equations, in quadratic expressions. That x squared, the degree is 2, tells us we're dealing with a quadratic. Okay? It's that simple. Don't make it any more complicated than that. When it asks for the degree, you just state the highest power on the variable. Okay? Sometimes there might be more than one variable. And if there is more than one variable, you're going to add those powers together. You're not going to see that, honestly, but I do want you to know about it. Okay. All right. Next. Here are 2 examples. Okay. What would the degree be of this first one, since there's 2 different variables? When you add the powers together, what are you going to get? 3. Okay, remember that there's an invisible 1 there, so the degree of that is 3. What about the second one? Go ahead and figure that one out.
6.
Okay, write it down. The degree of the second one. Again, there's an invisible 1 there. So what is the degree of that one? 6. Easy enough, okay? Okay. Last thing. When you find the degree of an entire polynomial, what you do is you find the degree of each monomial first, And whichever one's the highest, that's the degree of the whole thing, okay? So the highest monomial degree is the degree of the whole thing. So here's a couple examples, okay? For this first one, find the degree of each one. So what's the degree of this term right here? 2. How about the second one? 1. All right, the last one is kind of tricky, right? There's no variable. So what's the degree of it? 0, that's correct. Okay, the degree of the whole thing is just the highest one. So what's the degree of the whole thing? 2. That means it's actually a quadratic. And as we can tell, 4x squared plus 3x plus 7, that's something we worked with in the last chapter. Quadratics always have degree 2. Okay, go ahead and try the last one. That one's a little trickier because you have multiple variables. Find the degree of each term, each monomial, and then pick the highest one. Do that. Go. All right. The degree of this first term, the monomial, is what? 4. How about the second one?
3.
Ooh.
4. Negative 4.
3 or 4? Which is it?
4.
How'd you get negative 4?
Oh.
Because she's looking at the... Okay, so this is... Remember, there's that invisible 1 there. Okay, so this is 4. What's the last one? 6. Highest one, 6. Robert is correct. Very good. Any questions?